We're looking at the image now. What does that tell you, that halo of light around it?
As you see a cometary tail trailing the objects from behind. In this case, what we are seeing is a glow in front of the object. And now, as it approached closer to the sun, there seemed to be some teardrop shape to the plume of gas and dust around it.
NASA just dropped a bombshell that nobody saw coming. The mysterious interstellar object known as 3I/Atlas isn't acting like a comet. It's acting like something alive. Is something extraterrestrial finally heading towards Earth? Let's unravel the full story in video. The Cosmic Curveball. On July 1st, 2025, astronomers scanning the Chilean skies caught sight of something that made them stop mid-scan. A bright, fast-moving blur tearing through the void at 130,000 miles per hour. At first, it looked like just another comet. Icy, dusty, forgettable. But within hours, the data coming in from NASA's pipeline flipped that assumption on its head. The object, labeled 3I/Atlas, wasn't just fast, it was on a near straight shot through the solar system. Its orbital eccentricity? Over 6. That's not just unusual, it's record-breaking. Astronomers double-checked, then triple-checked, because nothing natural moves like that without a very strange story behind it. But the real headline hit during NASA's first public briefing. Images from the Atlas Observatory showed something no one had ever seen before: a comet tail pointing in the wrong direction. Instead of streaming away from the sun, this one was aimed directly toward it. That's not a glitch, that's a violation of basic physics. Dr. Bryce Boland, a veteran comet researcher, didn't mince words. The plume is blobby and it's going the wrong way. Every model said solar radiation should push the dust outward, but this looked like something was pushing back. Within days, more telescopes joined in. Gemini South in Chile, Lowell Discovery in Arizona. Same result. A bright, steady plume holding its shape, defying the solar wind like it had a mind of its own. And that's where the whisper started. If this isn't just dust, then what is it? Because something out there, millions of miles away, isn't following the rules. And that question? It's about to explode into a full-blown scientific mystery. Wait until you see what the James Webb Telescope found inside that tail, because the chemistry behind it is straight up alien. The chemistry that shouldn't exist. When the James Webb Space Telescope locked onto 3I/Atlas, everyone expected confirmation of a weird comet. Instead, they got chemical chaos. Webb's infrared spectrograph picked up something that made veteran comet scientists blink, then stare. The plume wasn't just odd, it was chemically impossible. The readings showed an insane carbon dioxide to water ratio, 8:1. For context, most comets sit between 0.1 and 2. The wildest outliers barely hit 4. 3I/Atlas blew past that ceiling like it didn't even exist. And here's the kicker. The carbon dioxide wasn't spread evenly. It was concentrated right where the sunward plume began. That means something on the comet's surface is actively shooting carbon dioxide toward the sun. That's not normal sublimation, that's directional behavior. Meanwhile, data from Chile's Very Large Telescope revealed a second anomaly: atomic nickel, in massive quantities. Nickel usually shows up with iron in normal comets. But this time, no iron, none, just nickel and a lot of it. Which means whatever's driving this thing doesn't fit any known solar system chemistry. So, what does that tell us? For one, 3I/Atlas probably didn't form anywhere near our sun. Its makeup screams deep space origin, maybe from a star system colder and darker than our own. But there's a twist. Because the levels of CO2 and nickel are so extreme, some researchers began whispering the unthinkable. Maybe this isn't just a geological quirk. Maybe we're watching controlled output. Think of it like this. If a comet suddenly started behaving like a spacecraft, how would we even know? The data was suggesting something that looked like thrust, not just evaporation. But the real jaw-dropper came when scientists ran the trajectory numbers and realized 3I/Atlas wasn't just glowing weirdly, It was moving wrong. The propulsive mystery. The deeper NASA dug, the stranger it got. Normally, interstellar visitors like Oumuamua or Borisov move along predictable gravity-only paths. But 3 I/Atlas? It started drifting. Not randomly, but sunward, the same direction as its bizarre plume. By mid-August, astrometric data from Gemini South showed that its path was no longer matching NASA's calculated orbit. The residuals, those microscopic differences between predicted and observed positions, kept stacking up. 0.1 arcseconds, then 0.4, then over 0.7. And here's the weird part. Every single shift pointed toward the sun. That's the exact direction the plume was facing. When scientists added a non-gravitational acceleration term into the model, suddenly the math fit perfectly. The acceleration was tiny, just a few 10 millionths of a meter per second squared, but it was real, consistent, and unmistakable. Something was pushing this object. Now, the obvious theory would be outgassing, jets of vapor from heated ice giving the comet a little shove. But the numbers didn't add up. To get that kind of acceleration, you'd need 10 times more gas than the coma brightness could justify. So researchers started running alternative simulations, models that mimicked focused, continuous thrust. And guess what matched? A narrow, persistent jet, exactly like an ion thruster. The kind NASA's Dawn spacecraft used to cruise the asteroid belt. That's when Avi Loeb, the Harvard astrophysicist who once suggested Oumuamua might be artificial, re-entered the conversation. If you wanted to slow down after crossing interstellar space, he said, you'd fire your engines toward the sun. The theory sounds outrageous until you look at the data. A stable sunward plume, consistent acceleration, heavy dust that refuses to scatter. All the fingerprints of propulsion, but with no engine to see. But that's only the beginning, because what happens when 3 I/Atlas vanishes behind the sun could rewrite everything we think we know about who or what is visiting our solar system. The coincidence that shocked scientists. When orbital dynamicists ran the numbers on 3 I/Atlas's trajectory, what they found didn't look random. It looked aimed. This object wasn't flying through the solar system at some weird angle like most interstellar visitors do. Nope. It was threading right through the ecliptic plane, the very thin path where all the planets orbit the sun. How rare is that? Try less than 1 in 500. And Atlas wasn't just aligned, it was flying retrograde, moving opposite the direction everything else spins. Imagine a car driving the wrong way on a one-way cosmic highway and somehow hitting every intersection perfectly. The simulation data got weirder. On its way in, 3 I/Atlas would pass within 29 million kilometers of Mars, then brush by Venus, then swing near Jupiter, all within a few months. The odds of that triple planetary alignment happening by pure chance? 1 in 20,000. That's not just rare. That's statistically screaming for attention. NASA's team double-checked everything. Could the orbital fit be wrong? Could observational bias be skewing the data? Nope. Every recalculation pointed to the same eerie precision. Some researchers started to whisper about intent. They didn't say alien out loud, but the subtext was there. If you wanted to map gravitational wells for a flyby, one analyst joked, this is exactly the route you'd take. It wasn't proof of control. But the level of alignment, the retrograde path, and the timing? It was uncanny. Like something or someone was guiding this visitor through the solar system with millimeter accuracy. But once 3 I/Atlas swung behind the sun, it disappeared completely. And what happened during that blackout raised more questions than ever. The Vanishing Act. By late October, 3 I/Atlas hit a point every astronomer both dreads and anticipates: solar conjunction. That's when an object slips directly behind the sun from Earth's point of view. For weeks, it's invisible. No optical tracking, no radar, no radio, just silence. For ordinary comets, conjunctions are no big deal. They vanish for a while, then reappear, usually brighter, as they swing back into view. But for 3 I/Atlas, this wasn't just a routine moment. This was the moment. Because perihelion, the closest point to the Sun, coincided with the blackout window. That means whatever was driving its mysterious plume, whatever was causing the sunward acceleration, would peak exactly when no one could see it. NASA's Deep Space Network couldn't track it. Hubble couldn't see through the glare. Even the James Webb Space Telescope had to wait it out. The entire global network of observatories went dark on the same target. And here's where the tension spiked. Right before conjunction, the plume's brightness started ramping up, not fading, increasing. It was as if 3I/Atlas was powering up for something, right before vanishing behind the solar curtain. For planetary defense teams, it was like watching a suspect disappear into a blind spot on security cameras. They could only sit and wait. Every simulation pointed to that exact window as the most likely time for an outburst or a maneuver. The Sun acted like a cosmic curtain hiding the finale. Would 3I/Atlas erupt like a normal comet, fragment, slow down, or, more chillingly, change course? Because when it reappeared weeks later, the readings didn't match the models. Its trajectory had changed, and not in a way anyone expected. Deja vu from the stars. When 3I/Atlas finally re-emerged from behind the Sun, astronomers were ready. Telescopes across Earth and in orbit snapped back into action, and what they found sent a ripple through the scientific community. The object was off course. Not by much, but enough to make jaws drop. Its position was shifted, slightly sunward, exactly in line with its mysterious plume. The same non-gravitational acceleration that had puzzled everyone before conjunction had continued through it. That's not supposed to happen. If sunlight and heat were driving it, the force should have flipped direction as the object passed perihelion. But it didn't. It kept pushing from the same side. Meanwhile, the data speaks for itself. A tail that points the wrong way. Carbon dioxide levels 8 times higher than water. Heavy dust particles that act more like exhaust than vapor. And trajectory shifts that line up perfectly with the plume direction. If this were a spacecraft slowing down after a long journey, it would behave exactly like this. That's not proof of intelligence, but it's not something we can brush off either. Some researchers see 3I/Atlas as a cosmic message in a bottle, a fragment from another star system showing us that our galaxy is filled with surprises. Others whisper about technology older and smarter than ours, drifting silently between suns. Either way, this interstellar visitor has cracked open the door to a new era of discovery. It's not just about what 3I/Atlas is, it's about what else might be coming. Because if there's a third, and a fourth, and a fifth interstellar object on the way, and the odds say there are, how many of them will follow the same strange playbook? NASA's next-generation telescopes, like the Vera Rubin Observatory, are already gearing up for the next encounter. But after this one, they'll be watching a little closer. Because when an object from another star system starts acting like it has engines, the question isn't just what is it anymore. It's who built it?